All right, so number 6 from yesterday. Describe the transformation that was performed. So you're taking a look, you got triangle ABC, and then you got A prime, B prime, C prime. I think it's pretty obvious which out of the 4 we've talked about so far this one is. Right? The size is changing. And there's only one out of the 4 transformations we've talked about where size changed, and that was yesterday's topic, which is called a dilation. Unfortunately, though, that's not going to be good enough, just writing the word dilation. What's always associated with a dilation? A scale factor, which I'm going to need provided here from you guys. Great, it's a dilation, but what's the scale factor? First question, triangle getting bigger or smaller as you go to the image? Bigger. So what did we talk about yesterday? What should you know about the scale factor if it's getting bigger or an enlargement? The scale factor should be? Okay, so when I write dilation with a scale factor, whatever amount we put next better be bigger than 1. All right, so how do I obtain this scale factor that's bigger than 1? The scale factor will be whatever the lengths of the corresponding sides are. All right, so is there a length we can, let's start with triangle ABC. Is there a side length that we can measure without doing distance formula? Because I don't want to waste time doing distance. Is there a length that you guys can find? I think so. So which length would you like to find on triangle ABC? 1? AB. Okay, everyone, let's find AB right now. Go ahead, find the length of AB. Let me know. Length of AB. 9 when you're ready. 8 units long. Now I care about the length of A prime, B prime, which corresponds to AB. And that should let me in on what the scale factor is. So go ahead, count. I know this is a huge count, huh? It's rare we have to count this many, but it is what it is. Meg, back to you. What's the length of A prime, B prime? 20. Good work. All right, so I know one side's 8, its corresponding side is 20. Now the question is, what do I write here? 8 to 20? 20 to 8. No, they're not the same. Totally different, and one's correct and one's not correct. What did we go about a minute ago? What did we say about the scale factor? Because it's an enlargement, it has to be greater than 1. So out of these 2, which one am I popping on for the scale factor? 14? 22? 20 over 8. So a scale factor, 20 over 8. If you don't want to reduce it to 5/2 or 2.5, that's fine too. Any one of these versions is fine with me. All right, so if you do say a dilation, let me know what the scale factor is, and that's how you find the scale factor. Are they similar? Are these 2 triangles similar? Yeah, they're similar, but I need to know why. They're not congruent, absolutely not. So don't mention the word rigid motions at all right, because they're not congruent. But there is one thing we know about dilations. They may not preserve distance or side length, but they do preserve what?
Angle measure.
Angle measure, and that gets them similar, all right? So dilations preserve angle measures. Thus, in conclusion, triangle ABC is similar, not congruent, to A prime, B prime, C prime. Anybody want to dig deep? I think we had 3 methods of proving triangles similar. Which one are we using here? If they preserve angle measure. They preserve angle measure. So which one of those 3 are we using here?
Angle, angle, angle.
Just angle is good enough. All right, by angle. We all good? All right, so I wanted to finish up that. Homework last night, I didn't, it was short. I don't need to assign any more problems other than the 3 I gave you. What did I want you to pick up yesterday? I needed you to pick up the following. When you dilate a line, and the center of dilation is not on the line, what do you know about the resulting line? It stays what to the original? Parallel, yes, it stays parallel. How do you find the new y-intercept? You take the old y-intercept and multiply by the scale factor. Okay? That's how you find the new y-intercept. You take the old one and multiply by the scale factor. And then the second thing we went over a lot yesterday, probably too much, what happens if the center of dilation is on the line? What do you know about the new line? Same one. Exact same one as the pre-image. So that's what I needed you to get out of yesterday's lesson. All right, how to dilate a line. So speaking of that, anything on the 3 problems you had to do? If you want to find the new y-intercept, you multiply the old one by the scale factor. And then the slope should be the same because they're parallel. Any questions? All right, I'm not going to waste time coming around looking for 3 problems. I figure an honors level class that should be already taken care of. All right, so I'll put the credit in later. There's no reason why I need to see it. All right, you ready? Yesterday was dilation of lines. Today is a dilation of a figure. All right, dilation of a figure. And there should be no assignment tonight, by the way. No assignment today. Okay? I don't need to. If we're doing constructions, I don't need you to practice even more than what we're doing today. All right, so first one here. Instead of dilating a line, I want you to dilate triangle ABC by a scale factor of 2. First question to one of you guys. Are the points, I should have also mentioned it's centered at the origin. So our center is the origin right here. So I'm going to ask you here, are points A, B, and C going to get further away or closer to the origin if my scale factor is 2? Point's going to get further away or closer? 21? Further away. Yep. That will result in a bigger triangle when we're done. All right, so like for instance, how do I make point A double its distance away from the origin? Right? I know it's a certain distance away. I don't want to use distance formula. I'm not going to show you that. How do I double its distance away from the origin? We're going to use slope. All right. Everyone start at the origin. And I want you to tell me how many up and over I need to go to get to point A. Up and over how many? 23. Up and over how many?
2 up to left 2.
Okay, up to left 2. Do it again. And you have point A prime. I'm doubling, scale factor of 2, doubling my distance away. So up to left 2, up to. There you go. I just doubled my distance away from the origin. All right, let me know. B, how far away is B from the origin? Give me up and over how many? 6, up and over how many? For B.
Up 2 over 1.
Yep, up 2 over 1. Guess what I'm going to do again? Up 2 over 1. And there's B prime. I'm doubling my distance away. And do it for C for me now. Somebody do it for C. 16 from the origin. Where do I need to go? Yeah, that's you can go down or to the right first. It's not going to matter. We're going to all end up in the same spot. Down 2, right 1. Down 2, right 1. C prime. Did I make a bigger triangle? Yeah. Because all my points just doubled its distance away from the origin. Connect them. There we go. That's how I dilate a figure. I use its slopes. And now, will I ever do this? I don't know. What if I change this to a scale factor of 3? What happens? One more time from each point. Yeah, do it again. Exactly. All right. All right, second diagram, scale factor 1/2. Points getting closer or further away from the origin? 1/2 now. 24, closer or further away? Closer. By a half. By a half. So let's take point A. How far is point A from the origin right now? How far is point A from the origin? 2?
Up 4.
It's up 4. So instead of going up 4, I'm going to cut it in half and only go up 2. Point A just got half as close to the origin, A prime. Let me do point E with you, and then I'll let you do the other 3 on your own. So point E, use your slope from the origin. How do I get to point E? Up and over how many? 8. Up and over how many to get to point E?
Up 2 and right 4.
Yeah, up 2, right 4. Cut it in half. I'll go up 1, right 2. Yeah, I'm cutting it in half. Up 1, right 2. There's E prime. See if you can do D, C, and B now. And yes, you can go up a half or over a half. It's possible. And hopefully you have a 5-sided figure that's a little smaller than the original. Why it does that? Questions from you guys as you move on to number 3, or any questions there on number 2 or the second one? All right, the center was at the origin. Guys, I can do this from any center. Any center. It doesn't have to be the origin. I can put the center anywhere on the graph, like I'm going to do for the next problem. And now the center's at 1, 2. All right, so now I'm just doing it from 1, 2 instead of 0, 0. Scale factor of 2, everything's going to get further apart. Make sure you start at the center when you count. Don't start at one of the vertices, count at the center. All right, go ahead, see if you can make it A, B, C a little bigger and make it A prime, B prime, C prime. I'll do the same while you're doing that. Your prime coordinate should never be on the other side of the center. Remember, the prime coordinate never on the other side. It's getting further away, never on the other side. Questions from you? How's it look? Just this graph and label, so there's no, I don't need to state it in this case. Everyone good on a graph now? How to dilate a figure on a graph. All right, we got to get off the graph now. I want to dilate these just in space. All right, and not on a graph. So how do I dilate in space? That is when you guys grab your straight edge and compass I do have a bunch of extra straight edges up here. Anybody wants a straight edge? How are we doing in the compass department? Because I guess since we take our masks off, I can hand you stuff out now. So if anybody needs compasses, everyone see the clear bin in the back. There's a small cardboard box. Make sure it gets back, please. Don't take it with you. Make sure it gets back. Okay? There should be a small cardboard box with compasses. I don't know how many their functioning ones are back there, but all right, let's do this. Here we go. I'm not really going to show you much. I want you guys to figure it out. So we're going to dilate triangle ART around center O. Scale factor of 1/2. First question. ART getting closer to O or further away? Closer to O or further away? 19? Closer. All right, so all these points got to come in closer to O, make a smaller triangle. How much closer? Half the distance closer. So everyone take your straight edge and connect R to O, because that'll be the distance from R to O. So let's take your straight edge, connect R to O for me. I don't care, but it's a certain distance away. All right, I don't care what that distance is, but it's a certain distance away. And where's R prime going to be? Half of that distance, wherever halfway point is. Anybody remember using this bad boy? Probably first unit, I think. How to find the halfway point of a line segment. How to find the halfway point of a line segment using your compass. Remember that one way back in the day? I know it's been a while. Hi, Caitlin.
Don't you like put it on one of the ends?
Put it on one of the endpoints. Go ahead, Ann.
And then you like open it up to whatever, and then.
No, we don't open it up to whatever.
Okay, like smaller than the line, so like bigger than half.
Thank you. That's the important part. Open up your compass more than half the length of your segment.
And then draw a curve, and then do it to the other side.
How big? I can hear you. There you go. There's your curve.
Like all the way through the line.
Like a half circle size, because we need 2 points of intersection. Half circle size. All right, now where do I go?
Then you do the same thing from the other.
Make sure you have the same opening of your compass. Go to the other endpoint. Hey, 2, not 1, 2 intersection points on these arcs. If anybody's getting ahead of me, do not draw the line through. So does everyone have their 2 intersection points? All right. Now, there is no need to draw that full line through. Where do I care? Where that line hits what? Yeah, RO, the halfway point. So I would just line up your straight edge right now, make a little marking on RO, and that point is R prime, halfway towards O. So line up your straight edge, make a little mark, and there is R prime. Everyone see? Halfway closer. Questions? Now look, am I going to take off if you just draw the line through and mark R prime? Nope, go ahead. I just feel like the less lines, the better for most of us. All right, ready? All right, now I got to get T and A closer. T and A closer, go ahead. So connect T to O, A to O, and cut it in half. So I know where the middle is. Use the one in the back. Come on. Best one in the house. Behind the chair back there.
Oh my god, the kindergarten. In kindergarten. I need a sub. And the sub sent me down to the office because she thought you were sick. And she like kept sending me off. And the nurse was like, you don't have to come in. Yeah, I can't. So I'm going, I'm talking about construction. Hold your thing at the side. You right. Can we like erase the markings down there?
No, because that's how I grade it. Whatever gets the job done, that's what I said.
Oh wow. This is color coded. Yeah, but it gets the job done.
So hopefully you got a smaller triangle now. Make sure you don't have anything on the right side of, oh, nothing should ever be on the other side of your center of dilation, on the same side. So go ahead and finish up, and then we got to talk about, well, how do I make it bigger then? Go the other way. All good? We all good? Any questions, Scott? Cut it in half before we double it. All right, here we go. Construct the dilation centered at B with a scale factor of 2. Well, good news here. Let's start here. It's centered at B. Where's B prime going to be? Same spot. Here's B, and here's B prime as well. It's not going to move. All right? Can't get closer or further away from itself. But we do have to double A and C's distance, right? We do have to double it, get it further away. All right, so how do I double the distance away with A and C? Everyone take your straight edge. Extend AB, right? Extend AB. Somebody tell me, how can I use my compass now to find where A prime is going to be? Doubling the distance away. Think about it. Come on, use that contraption. Use it. Jonah got a suggestion.
You put like your compass point on B.
Yep.
The pencil tip on A.
Yep. Measure the distance from A to B.
And then you like move it to A.
And now double it. Yeah, move it up to A. And there you go. Make a nice little arc mark, nothing huge. And there's A prime. And there's A prime. And then let's do the same thing for dilating to point C. B to C. And then let's make triangle A prime, B prime, C prime. Look good? And I went over, I think I went over this too quickly. When it's centered at one of the vertices, everyone good why the vertice stays where it is? We're good there? Okay. All right, and then we have to just answer this question. Is the image similar to the original? Is it similar? What did you just do to ABC? We dilated it. We know, yeah. Yes. Dilations preserve angle measure. Thus, the triangles are similar. By angle. Rigid motions preserve both side length and angle measure. Dilation is just angle measure. Okay, you are on your own for that last one, and you're good for today. No assignment. No assignment.
No. Every single day. I'm sorry.
And then we start review for Tuesday's test tomorrow.
Someone from That's exactly what I was going to do.